like spread to you guys. So it was a simple task where you had to use the MNIST dataset to train any model. Okay, so and then if you haven't, you can try it. There are no issues. Uh, you'll uh, there are questions like the challenges you faced, and half of the part for this session was maybe where we can like help you solve whatever problems you were having. But even if you didn't know about the form, or if you still haven't filled it, you can still fill it. We'll try to like I hope I'll be able to resolve your questions here so that it's easier for you to train the models. Or maybe if you want, you can fill the form, and later on we can try and resolve your questions if you feel like if it hasn't been answered already. So you can still go ahead and like fill out this form, or like do this challenge and fill out this form. And then you can like and then you can send us your questions. Chaitanya, can you share the list of questions that have already been sent to me so that I can just start answering them? Or if it takes a little time, I can move to the next part for now.
So you can move to the next part
Okay. Okay.
now.
Okay. So while Chaitanya figure out the questions that have already been submitted, I'll move to the next part, which I had planned, which is basically helping you guys set up your project repositories, uh, a little bit of code management, a little bit of ML ops, a mixture of both. Right. This will help you like we have already covered basics of Python. Right. We have covered some intermediate level of code, some basic level of code, that the first session that I took, right, where I think I shared a collab notebook with you guys. And then we have covered the theory part, right, where I explained all the machine learning models and some basic machine learning models, the rationale behind them. And then I guess there was another session with for a high level machine learning, like deep learning and all that you might have attended. uh, Now what I want to do is help you guys manage your code. Say you have started a Kaggle challenge, or you are participating in a hackathon, right? And or maybe say you are a machine learning engineer, you have joined a team, and now you want to like start collaborating with other people. And you are creating models, you are deploying models. So how do you manage your code? How do you manage your tasks? So I have in like I have come across multiple solutions, but there are like two solutions that I generally prefer. Sorry, I'll share again. Yeah. So it depends on the scenario that you are in. So in some companies, the people who are developing the model and the people who are deploying the model are within the same team. And in some companies, there are two different teams with two different managers. Now that changes the dynamics a lot on how you collaborate. So first I'll take you through this same team option, because when you are starting out and when you are doing your own projects, you will really you'll really find this helpful. Uh, and and what I'll do is I'll put it on GitHub as well, so that you can always use this as a template, right? So for a basic Python project, you'll first use either a make file or a build file. Normally when you are doing personal projects, you don't use such things, right? Because you're not doing the project on a very big scale. You just want to train your model and get the results and submit it to the competition, right? But ideally you should have a build file, which would basically compile all your code, and like which can through which you can basically decide which part of the code to run. Because in a big project there can be multiple parts, and it's not necessary that you run all the parts together, right? So the build file or any build tool that you can search online will really help you. So I have some examples. If you're using a make file, the most common uh, tool to use is CMake. And if you're using a build file, you can use Python scripts. There's setup.py, build.py. You can search online, you'll find a lot of info on that. Setup.py is the default Python uh, way to create modules. And then there are softwares like Bazel, like there are build tools that can help you manage your projects, so you might want to check them out as well. Okay. The second requirement, the second thing that you should prefer is a project.toml file, which can basically be a complementary to setup.py file. Or what you can do is you can use a what do you call poet you can use a package manager like Poetry. So this will complement the requirements.txt file, where you can use pip or Poetry. Uh, right. So I would suggest that you use Poetry if you are going for a big project, but for a small personal project, pip should be fine. Why you should use requirements.txt? So that you have an idea of what the base setup was when you come back to your project later. Because a lot of times what happens is the packages get updated and then the code breaks, right? So it's very difficult for you to figure out why it's breaking or what's happening. If you have the base packages sorted out, at least you know you're working on the right environment, like the right pandas version, the right keras version. And just for example, pandas released 2.x, right? And it removed some of the functions like append, it changed some behavior. And old pandas code, some of the old pandas code started breaking. So using paper Poetry can really help you with that. So but these two things are only required when you are using when you're working on a big project, right? And then there is a standard Docker file which will help you like containerize whatever you're trying to do. This is like basic engineering stuff, right? Along like you can, it doesn't matter if it is a ML project or not, you can still use them. And then there is a docs file. You should absolutely try to document whatever processes you are building. Otherwise you'll get really confused later, right? Now, and then there is a test folder. Um for ML, the testing is a little more complicated, so I'll come to it later. But these are the general uh, uh, engineering standards that we use. Now, coming to ML specific parts, you can see there is a blob store. Okay, so blob storage, generally, if you type blob storage, it will show S3. I'm a AWS S3, right? Which is the most popular type of storage. But if you want, you can say, if your project is not that big, if you have a lot of memory, you can save all your files in your system as well, right? But this file just indicates that okay, you should have some sort of uh, file storage facility like S3, right? And within the blob storage there are two parts. There's a model part and there is a data part. So it might happen that you end up training a lot of models for a given project. Like you might try uh, say a simple CNN, then you might try a mobile net, you might try a transformer, you might try a lot of things, right? So in the model store you can save all those files, and you can keep a track of them. Same with data. uh, with the data, you can save your MNIST data here, right? You can save you can organize it in whatever way you want, but you should have a folder where you can go and check all your data, right? There is a notebook section. Okay, so most of your ML engineering or data science engineering will involve uh, say experimentation, right? And the best way to do experimentation is on Jupyter Lab or Jupyter Notebook. uh, that is one of the best tools for like just going in there, inspecting the data, and uh, like running smaller parts of the code and figuring out what's wrong and not. But managing those Jupyter notebooks gets very tedious, so you should absolutely have a section in your project where you're storing those notebooks separately. Inside the folder you can you can manage it however way you want, but at least have a directory for that. There's a folder for reports and benchmarks. So this refers to all the outputs that the script will generate. It can be a Excel file which will have the final results. It can have the matrices of how long it took for the process to run, right? It can have all sorts of things. But the main point is that you should have a section where you save all that data, and you should save all that data. You should save how much time it took, how much memory it took, what was the error against the validation set, uh, which I'll come to later. But all sorts of benchmarks, all sorts of logging, not logging, all sorts of benchmarks and all sorts of outputs, visual outputs, you should save inside this folder. Now, coming to the main part, you'll have three main sections. One is the input, one is the main algorithm, and one is the output. For the input, you have the features folder where you can have files like, okay, downloading your data set, okay, then applying some pre-processing to it. Once the ML model is done with the data, you might want to apply some post processing on it, so that it like so that it adheres to a particular standard that you want, right? It can either be the output that the organizers of the hackathon want, or it can be the output that your manager wants, or it can be the output that uh, the external team wants, whatever it might be. Okay, all the data related scripts should be saved in this folder, and then you can manage them. The models folder will have again have these scripts. The training and inference scripts are obvious, right? And then there is a model.py. So you don't necessarily need a model.py. Like, it depends on the type of tools you are using. If you want, you can save the skeleton inside the models.py. Like, you can save your whole code, how it builds different CNNs, or how it builds the random forest model, whatever, right? And then you also need to have the location of the weights. What I hope you are familiar with the terminology weights, but if you're not, it's basically the uh, parameters corresponding to the neural network. Okay, so there are parameters, and then there are, in neural networks there are parameters, and then there are hyperparameters. Parameters are generally called weights, which get assigned to each and every node of the neural network, right? And then there are hyperparameters that we save separately, which, like I said, you should save inside the benchmarks and report section, like what sort of hyperparameters you ran the model with, right? And if you want to go a little advanced, like if you're not doing a personal project, if you're doing a big project, maybe you're in a company or something, you can use model store, which will save the skeleton and the weights, and it will also version your models. So the, you can use all sorts of tools for model stores. One of the examples is ML flow. Okay, there is DVC, and then there is ML flow. Both of them are very good tools. You can check them out, and they'll help you manage all your models, your like whatever skeletal structure is there. Generally it's saved in a JSON file, but with keras and tensorflow, but it can vary, right? And then there is a weights file which can be like .pb, .h5, whatever, right? And once the model is trained, there is a validation section. So validation is like testing for the model. There's a train, generally there is a train set, there's a validation set, and there's a test set, right? But for the validation or the test set, you might want to run a separate script and detach it from the training script. When you're doing a project alone, it won't really matter, but when you are doing a big project, you would want to like log your all your validations in a different file, so right, so that you don't get confused. The last section is the visualization. Once the model once the inference section is done with dumping the outputs, you can run the visualization scripts, right? And like you can run, you might want to run this script, and it might generate a, say, a png of a png image, and that png image can contain all sorts of bar graphs and charts, or it might contain a transformed image, or whatever your output is. So these are the three main sections of your workflow. If you're, say, you're computing for hackathon, right? You might want to go a little low on the visualizations part. You still might want to use it as post analysis to make sure that your model has a good accuracy. But in general, if you're only concerned with the results and not with presenting it to someone else, you can do with these two folders, right? But ultimately, once you start doing more and more projects, you'll need to have a visualization section as well. Okay, so this is a good setup if everyone is working in the same section. But what happens is, generally, in big companies, there are data scientists who are building the models, and then there are machine learning engineers who are deploying those models. And generally, they are in different teams, and they have different ways of working, right? So for that, the project structure becomes a little different. So right off the bat, we have divided the code in two sections. One is research section, one is production section. Obviously, you can guess who will work in which section. But it is important to have a util section which will contain the common code utilized by both of the teams. And it is really important to have to define and agree upon such common code, so that people are not doing different things. And then because ultimately, if you're working in different teams and the other team is doing something different, you'll get stuck when you are trying to deploy it, right? Or if and then you'll go back, and then depending on which side you are, you'll have to redo your work, right? So what are the examples of what common code you can use? One is upload and download. Like whatever model you want to download, whatever features you want to download, maybe you are using ml flow, maybe you are using simple s3 boto 3 functions, whatever it is, it should download it in a similar way. The second thing is model or store, or a feature store sign off script, which is basically like saying that, okay, now this particular model can be shifted from the research folder to the production folder, right? So you might, if want to do it verbally or on mail or something like that, but ultimately you have to label a tag a model, okay, and say that, okay, now it is being shifted to the it is ready for deployment. So doing it programmatically might be much easier. Going into the research section, uh, you have a benchmark folder where you are going to save all sorts of hyper parameters on which you train, right? Like what was the learning rate that you used, what was the optimizer that you used, and stuff like that. In the develop section, you can have multiple Jupyter notebooks. You can do all sorts of experiments. Once you're done with the experiments, you can shift them to scripts in the deliver folder. Here you can have different model scripts, feature scripts, and test scripts. Okay. This process comes in handy because shifting from Jupyter notebook to scripts can take a certain amount of effort, and if you separate these two tasks, it will become easier for you. If you Because you might create this model one, and then you might do more experiments and then edit this model one. So, and shifting from Jupyter notebook to a script can introduce some anomalies, because Jupyter notebook has a much uh, free flowing environment, but for scripts you need certain things in order, right? So it's a good practice if you just separate those two things out initially. Then again, there is a feature store and a model store. uh, in feature store, you can have your raw files and your processed files. uh, this will help you log what you are doing, like what was the input data, what sorts of transformations you did. Not just logging here in benchmark, but saving the outputs in feature store can be really helpful. Then there is versioning. I'm assuming that if you're working with different teams, you absolutely need to define different versions so that the wrong model doesn't get deployed, right? And within the versions, you can have whatever data you want. You can split your data based on the end predictions, like say, like I'll take a very basic example, say cat and dog. So you can have two folders here saying cat and dog, and if I open a folder, you can have multiple images of dogs. Or you can do it based on the breeds of dog as well. And the second thing that you can split it on is this testing stages. Instead of dogs and cats, you can have like test, train, and validation, or whatever sort of labels that you want to give, right? So these are the things. Now specifically for feature store, you will want to use certain sort of labels or tags to mark it as in development, because you are continuously uploading your data and your models inside the feature store, and you don't want others to use it. So you just tag it. What you can say dev, you can write your own name, whatever it is, but you just indicate that okay, you are still working on it, right? Similarly for version 2, you'll have such data, and for processed, you'll have such data. This will give you, even if you don't use feature store, even if you just use uh, this folder structure, and if you can like agree upon a good versioning strategy, then you are good to go. You can read more about different versioning strategies. Python versioning strategy is a good starting point, but for ML models, it gets more complicated really quickly. So you might want to read into it, and if you are working on that level of project, you might want to use a feature and a model store. So even for model store, it's similar, and there is no raw or process, nothing like that, but still I would suggest that you use some sorts of versioning, right? And you label your if you're using a model store, you tag it as dev so that other people don't use that model, right? Then there is a visualization folder where you can dump your visualizations. Obviously, if you are developing something, you might want to like dump the data and see what's going on, right? So it's good to have a folder where you're dumping all your data. And even for visualizations, you can have a versioning system. You can have something like a project and project level, right? And or the module level, and then there can be a subroutine, like if it's a particular function or particular set of functions that produce that output, right? And then there can be a purpose, okay, like com- let's take a simple example of a stock market predictor, right? You can here you can have this like say bank nifty or something like that, and then you can have SBI, or like you can say top growing or low valuation or whatever, right? And you can keep defining and come up with a versioning strategy and use that to save your visualizations, because the versioning strategy will help you sort your outputs as well, not just the inputs, right? Now once you are done with the research, now once you have finalized your deliver folder, once you have marked those particular models as ready for production, uh, it will be handed over to the engineering team, and they'll start their work in the production folder. Here also they'll have a blob storage, right? Because there might be some files that they need to save. Might be they are using S3 and they need to download it, right? Or if they are using a model and a feature store, whatever the case. So in big projects there are certain situations where you have to retrain the model on the latest data available, but it doesn't require any research. It's like, okay, the trends have shifted. Let's say you are predicting user behavior for whatever online purchases they are making, or like the previous example where you are trying to figure out the stock market, right? If is You can go back to like 2 years, 3 years, 5 years, 10 years, but data from say 20 years ago might not be that relevant, right? So you want this is called something called online learning, right? Where you only look back to a certain extent in past for for validating your data, and uh, whatever data is present before that certain date, you just ignore it. So in that case, you need to frequently retrain your model on the latest data, even though the skeletal structure of the model or the main algorithm doesn't change. Your data trends change and you want to use the same model with the new data. So you'll have a training section here, right? Then there is an inference section, which is basically it will pull whatever latest model is there and it will start uh, predicting. Here I have written app or infer. So app can be a API, a REST API, it can be anything like that, right? Or it can be a inference script, which basically loads the model and dumps the prediction based on whenever the script is triggered. If you are using a API, it will keep listening, and based on the event that happens, it will predict. And then there is a visualization script, because if you want to generate any reports or any graphs or anything, you will use the inference output to do that, and then you can save it again in the report store, right? In the reports you can have CSVs, you can save the matrix, like, right? Because how will you know when the trend has changed, right? For that you need to store the input out for that you need to store the inference output somewhere, right? Which you can do using this matrix files. So uh, I've told you why you would want to have a training section in your production files, why you would want to have an inference section. Docs are important because obviously you are deploying here, and like you want to document the whole process and how it interacts with different services. It can get complicated, right? And then are some internal common scripts. What can they be? They are the model and the feature files that you received from the research team. Okay, this also becomes important. It has the same thing. You can either you'll have to load it how the way the research team decided it, right? So you need that knowledge, and this common script will be used both by the training and the inference scripts. That is why it is in a common folder, because if you create multiple copies, you'll end up missing some of the changes. So it's better to have a single folder. Then there are prod tests. These are basically the normal Python tests that you might want to run, because apart from having models, you might have some other services running as well. So it's good to have general engineering tests to make sure that your code runs the way you want it to. Uh, these are again the common files that you need while you are uh, running the project, and especially when you are deploying it. You might skip it during the research phase, okay, whatever way you want, but while deploying it, you need to have some consistency. So highly recommended that you use it. Okay, so these are the two like project structures that you might want to use. This one is the most common one. You'll find it everywhere online. Some variation of it, like people, it's you'll find something similar. People keep changing small bits based on their past experiences, like I have. And then this is the one that I found online, and I have modified it based on my experience. But this is the one I find it, that works in when you are working with multiple teams. So maybe when once you have reached a certain level, once you are like in your job, when you are interacting with multiple teams, uh, it will really help you out. But in any case, if you just want to go for a kaggle competition, you can just I'll just upload this to GitHub. You can go there, you can copy this particular file, and you can start editing. You might not need like certain folders like these, or files like these, but it will really help you if you just want to quickly start with a certain project. Okay. uh, cool. So this is how you should manage, basically this is how you should manage your code and your ML projects, so that it's so that you can also figure things out easily. Because as you start developing more projects, you'll realize that it takes more time to manage your work than to actually develop the models. uh, okay, let's look at the questions. Okay, Chaitanya, I think there is some question for you regarding the uh, certificate. Apart from that, if anyone else has any questions related to like managing their projects or working on hackathons or something like that, maybe some of you have already worked in some hackathons. So, like as part of a team, or maybe you have participated individually. Uh, uh, Chaitanya, can we do a poll for that? Hello, people, am I still online? Can anyone confirm? Hello. Okay, Helmi says hello. Hello to you as well. Okay, so I am online. Good to know. Let's wait for Chaitanya. Um, guys, I'm not able to reach out to Chaitanya. Let's wait for him. Till the time, if you have any ML questions, I am here to answer them. Uh,
Hello,
so,
hello.
uh,
Hello.
Hi, Chaitanya.
Yeah, I think there was some issue with my net. Sorry. Yeah. So
Okay, so I'm done with the explanation of how they can manage their own projects. Now I have opened the floor for more ML related questions. But people are have questions for you, like certification and attendance sheet.
yeah, yeah, yeah. So we'll share a certificate form. I mean, a attendance form, and based on that attendance form, you will get a certificate. But we'll share that form at the end of this session. So I wanted you to focus more on the technical thing which Vibor is teaching rather than certificate and these things. So don't worry about the certificate. You will get the certificate, but first focus on the learning, which is more important. So that's why I didn't uh
Mm.
or
That's okay. I think I'm done with whatever I prepared. Now it's only left with for live questions. So you can share the form, and if you have any questions, you can post it. Uh, Otherwise, we can conclude.
guys, if you have any questions, feel free to ask Vibor. He's there to help you. Anything, whatever he shared, or anything related to machine learning or building a career in machine learning, anything related to that, just feel free to ask in the Q&A section. So
Okay.
yeah, we will wait for another 5 to 10 minutes for you guys to think of the questions and write down. If you have any questions, just feel free to ask, and then after that we'll wrap this
Yeah.
session.
Yeah. Okay. I think there is one question, and it's a very good question. It's regarding the projects you can do to boost your resume, right? So, uh, apart from the basic projects like the MNIST project that we told you to do, right, is a very basic project, and it might not add to your resume. No, it definitely will not add to your resume, right? It's only for your learning. But if you want to add to your resume, what I would suggest is you do hackathons and other ML competitions. Okay, that is a very good way to practice and to add to your resume. Apart from that, if you don't want to if you don't want to limit yourself to these competitions, if you want to do something that you can showcase, that you have worked on for 1 or 2 months, then there are other options as well. Um One of the most basic ones that I suggest everyone is try to mix ML with other technologies. Like try to build a small app that can detect faces or something like that. Like, or maybe put your model on a browser. What will happen is that you learn about other technologies that support the machine learning model, and you'll also learn about the deployment process of how, once you have created a ML model, you need to convert it to different formats. You need to make specific changes for it to work in different environments. Like for mobile, there is TensorFlow Lite package. There are a lot of other packages that you can look into, but that is one of the most famous packages that can help you convert your models, right? For if you want to run your models on a browser, there is TensorFlow.js. Okay, this you create something using Keras or TensorFlow. You use TensorFlow.js APIs to convert it, and then you can use it on a browser with, say, uh, any other JavaScript technology on front end, right? That would be a like good demo project. And right now, people are a lot into like LLMs and all, so you can go for that, but don't forget about other complicated projects that were there before the chat GPT hype. Like there are models uh, that can just input, take an image as input and then describe what's happening in the image, right? So maybe you can just train that sort of a model. You can put it on a browser, you can create an API or something. You can ask people to like you can give them option to click an image, and as soon as you receive an input, you start describing, okay, there is a man sitting on a chair, right? Stuff like that, a little more interactive, uh, that will engage whoever is viewing your project, and that way you'll have a better chance of getting a reply from some company, right? So I hope that answers your question. Yes, I'll share the GitHub link. The GitHub link will be shared by Chaitanya after the session, within a day or two. Machine learning, but it's more inclined to natural language processing. Feel more proficient. Yeah. So I think it's related to the first question, whether you want to be more proficient, whether you want to attract more companies. Uh, you have only two ways. One is by participating in hackathons. Second is by implementing certain algorithms that are certain difficult algorithms, right? But the issue with these difficult algorithms is that you'll need a lot of compute power, right? But again, now it is much easier because Google gives free GPUs for like a few hours. Kaggle gives free GPUs. It has a certain quota, like around, as far as I remember, 10 to 12 hours per week, something like that, right? And there are other resources as well. Uh, but ultimately, just training more complicated uh, models won't help you. You need to integrate it with different technologies. Like here, you have mentioned word to vec and other such things, right? So coming up with a scenario on your own is very difficult. But if you join a hackathon, they'll give you a problem statement, right? And that way you'll be able to innovate within a certain boundary, and that will help you innovate. Otherwise, you can just pick up a practical scenario and start working on it. But if you start working like that, you'll have to dabble with multiple technologies, like app creation or website creation or something like that, which will become a little more difficult, even though it will give you a very good experience of how the overall projects work, and it will make you a more desirable candidate, but it will be a very tough task. But if you start doing it on your own, you'll get 100%, you'll get confused, and it will become very difficult. So try to do it in a defined boundary, and within that boundary, to add on to that, like you're trying to merge BERT and integrate it with word to work or something like that, right? Within that particular problem set, you can experiment all such things, and then you'll have live output of whether your experiments were successful or not. Because if you just train a model and put it online, right, it's very hard for you to like judge its accuracy, and you don't want to send something out to a recruiter and then have them try it and realize that it doesn't work. That would give a very bad impression. How can we build a portfolio? Can you, where we can post them? No, it is not different from posting on GitHub. If you want to build a portfolio, keep doing, uh, like you can either put it on GitHub or you can have it on Kaggle, because in Kaggle as well you can save your whatever work you are doing, right? And then you can make it public. So just just stick to one or two platforms like GitHub and Kaggle, right? And start working on your projects. And it's like the 100-day coding challenge. I hope you might have heard of it, but if even if you haven't, it's you solve one problem every day without fail. That way, within more than 3 months, you would have solved 100 problems, and you will become better than much better than you were, because you have been practicing consistently, right? So it's similar to that. If you want to build a portfolio, since ML projects are a little bit, say one project a month or something like that, you you try to, or whatever comfort level is. There are a lot of online platforms that will help you practice machine learning problem statements. I've just mentioned the most popular one, but you need to consistently do projects, or those projects can be your participation in a hackathon. You just take the code, you put it on your GitHub, right? Or or if you are doing it a personal project, you can just commit every day, do something, right? And if anyone just checks your commit history, they should be able to judge that, okay, this person has put in a certain hours of effort every day. Even if the project is not mind blowing, it will still show your consistency and commitment, and that would add a lot of value to your portfolio. Where can I learn about how to deploy trained models into a website? Okay, so like I said, TensorFlow.js uh, is one of the packages that can help you do it. You can go to their website. It is TensorFlow has a very big and good ecosystem. You can just go online and you can check their documentation. They have very good scripts to uh, and videos, so that you can start out. Uh, I'll just wait. I'll just mention it here as well. And if you want, like, some other packages, once you are familiar with one package, you can go and search for familiar packages by like a simple Google search. You can say alternative to TensorFlow.js or something like that, so that you know about more packages and you're comfortable with the whole process. If, uh, so Mohan says, if you start in beginner level, I think the question is incomplete. Or did I miss anything? I don't think I missed anything. Mohan, if you can just complete your question. Yeah. Also, I'd like to add one thing. I mentioned that, like, sending your project to someone, say an HR, and then it not working, it doesn't mean that your code crashes. Because the difficulty is with ML model is, even if your code is running perfectly fine, your predictions might be really off. So it's not just about making the code work, it's about making the and the model work together. So that is why you need consistent feedback on how your model is performing. And that's why we have different test scripts like validation scripts, uh, to make sure that such instances don't occur. But again, building that validation set, building that validation script is also uh, time consuming. Okay, someone has raised their hands. Christopher, I'm not sure if I can grant you mic access. If you can just ask a question.
Christopher, please ask your question in the Q&A section. You raised your hand, so please ask your question in the Q&A.
Yeah. And if there are no more questions, I think we can conclude. Chaitanya?
Yes, Vibhor.
I think there are no more questions.
Okay.
Okay.
Yeah. Yeah, so thank you so much, everyone. Thank you, Vibhor, for taking your time and guiding students about this machine learning and ML ops and so many variety of topics. So thank you so much, and thank you so much, everyone, for joining today. We look forward to see you all in the next session as well. But before that, before we wrap this up, there's an announcement. We are having a Kaggle competition very soon, and that will be a machine learning challenge. But before we launch that Kaggle competition, we want you to fill this Google form and participate in this other challenge, that MNIST dataset challenge. So, so it's like a level one will be this Google form that I shared, and level two is the Kaggle competition. So before we jump on to level two, we want you all to participate in level one competition. And it's very beginner friendly. It's very easy, very basic uh, challenge. And yeah, we highly insist you to participate in this challenges. So anything that you want to add, Vibhor, on that, about that challenge? I think Vibhor is. Yeah. Yeah, so I think Vibhor has left, but anyways, so I hope you all had a great learning experience, and uh, and I know what you all are waiting. You are waiting for the attendance form. So yeah, I'm sharing the link. So we'll share the certificate uh, by Monday, but we want you to fill out this attendance form. I hope you can access this. AI/ML StudyJam certificate form. Write down in the write down in the Q&A section if you can access this. So do participate in this machine learning challenge. The first challenge is with the Google form, MNIST dataset, and the second challenge is will be at the Kaggle platform. Cool. So you can access the form. Then uh, everyone, please fill out the attendance form if you want the certificate for this session, AI/ML Study Jam. And also do join our community if you haven't. Let me just share the link as well. And I hope you all are already part of our WhatsApp group. If you don't prefer WhatsApp, then we also have a Discord community. You can join it over there as well. Also, do follow us on Facebook, Instagram, so that you get updated about our upcoming events. So I have shared the when we will get our certificate. Does this certificate add up in our profile? Yes. So you will get a certificate by Monday, and this will add your profile. You can showcase to anyone that you attended this session, you participated in ML Study Jam session, and we highly recommend you to participate in the ML Study Jam challenge that we are running. The first challenge is for with the MNIST dataset, and the second challenge will be on Kaggle platform. That will add a lot of value to your profile. So do participate in the challenge as well. It's a very first challenge is very basic one. So whatever we have covered till now, we are just checking the knowledge or checking your knowledge on that. So it's very basic challenge. I highly recommend you to take part in that. So I have shared the link. Please share the Discord link. Yeah, I have already shared. I hope you can access the group and you are a part of our group, this either Discord or WhatsApp. And thank you so much once again for joining today. I hope you all had a great learning experience. Now I'll end this call and look forward to see you all in the next event as well. So thank you. Bye. Thanks. And also the learning material, the resources will be shared by the mail. So certificate, learning material, GitHub link, everything will be shared to you by the mail. But in order to we share you all these things by mail, please fill up the attendance form. Thank you. Bye. Take care. Have a good day.